So, like I said, make sure you download the Greenlight package. We'll start with this drill4 script. But as I was just saying, the way I've planned out today, I'm hoping that most of it you can work on in class exercise on your own. I'll be here for questions. It's basically just a practice problem to see if, to see how you're doing in terms of analyzing data and that sort of thing. For the first part of class, I'm going to go through pretty quickly how to do multiple comparisons in R. It's not like super complicated. There's two new functions to learn. There's d.adjust and shift_a.test. So we'll be using this prestige data set. I don't know how much Austin's been using it, but I kind of analyzed it to death when I was teaching the applied part of the course back at UW where I got my PhD. Occupations with their prestige, their level of prestige and their level of income. You probably also learned that there are like different ways of handling contrasts, handling categorical variables in R. So in this script, I'm mostly relying on bar contrasts, which is a way of setting contrasts within these factor variables that it's one of the ways that R represents categorical variables. So if you want to use bar contrasts, this is not the only way that you can do this, but if you want to use it, you need LM support. The way bar contrast works, you can specify either POCs or dummy codes in the second argument. And if you're using dummy codes, you set the reference group by saying ref level equals 1, for example, and that sets the first, the group that comes first here is the reference group. And if you're using this method, when you do your call to LM, instead of doing LM tilde C1 plus C2, you do LM tilde whatever the factor variable is, and it'll then the model with the contrasts, however they happen to be represented in that factor variable. It's just an alternative way of doing this.
But you could do it either way.
You could. I find that it's often easier to work with factor variables when you're graphing. And it's also handy to work with factor variables if you want to get descriptives within different subgroups. So there are certain things that I find factor variables convenient for. Most of the time, I just find it kind of annoying that R has these like separate tracks where I'm not like super a fan of how R handles categorical variables. Anyway, this is just showing you that this is another way to get you at the same answer. Yeah, and I have a bit of code down here below, just showing you that you get the same answer if you actually create C1 and C2.
Actually, would you mind if you turn off the lights?
Oh, yeah. Could you hit the light switch?
What is the case when type thing that you were doing?
Sure. That gets you the same thing. Case when is a function in the tidyverse. And sometimes it's a little bit more convenient than if else. If else comes in the base R installation, and there's sometimes where I don't want to be like working with all these different packages, and so I just use if else. But the only difference if you do case when is I use the tilde to say if this is true, give it this name, and then there's, if you want to give a condition, just if you want to say otherwise, you say true. So what this does is it says, if type is equal to white collar workers, do the thing after the tilde, give it a 1. Otherwise, give it a 0. So it's the same structure as if else, but with if else, you might have, I'm not sure if this has come up for you, but you often have to put multiple if else's that are nested within each other. So like after this, in the second part, you have to put another if else that says, okay, if this is true, do this, otherwise do this, otherwise do this. And it gets to be kind of a mess. The reason to use case when is that after the comma, you can put as many different separate conditions as you want. So if you want to say type equals prof do a -1, that's how that syntax would be structured. Using if else is just a little bit more work. So you have to do if else and then 1. But then if I want to say if it's prof, give it a -1, I have to put another if else here. And so it ends up being just a little bit harder to read. Is that clear for everybody? One of the reasons to use case when is just that it's easier to read and easier to figure out what you're doing. They'll both get you to the same place. Questions? Okay, so this is just showing you that it gets you to the same place. Oh, whoops. It should be BCV, white collar, and BCV prof. It's there was an error because it was just the wrong variable names in here. So that it should say BCV white collar, BCV prof. Oh, another note about naming conventions. So in class, I've been calling contrast variables C1, C2, C3, mostly to show that the process that you follow for the different kinds of contrasts is very similar. When I'm actually working with contrasts for a specific project, I like to give them kind of descriptive names. So that first contrast, for example, is it compares blue collar workers to white collar workers. So it makes sense to call it BCV WC. That's just my preference. You of course can use whatever naming convention you find useful for work, but this is something that helps me keep straight what I'm actually doing. Right. In this next bit, I'm just changing the reference group because in that first model where the reference group is blue collar workers, it's missing a comparison that might be interesting in an exploratory sense. So it's not comparing white collar workers to professionals. So this gets you that extra contrast. But if you're looking at that extra contrast, chances are you're in this exploratory mode. But anyway, this is how you get that information. All right, so hopefully that's familiar stuff. To actually do a correction for multiple comparisons, you can do the Holm-Bonferroni method, or I talked about Chaffee in class as well. The Holm-Bonferroni method is implemented in a function called p.adjust. That's down here. And the structure of the call to p.adjust is you just give it a bunch of p values. So you could literally type them out. You could type out 0.001 0.05, 0.10, you could just type them out in your script, that's fine. If you want to grab the exact p-values that were calculated from LM, you can use a process like is shown up here. So the p-values are stored in this thing called coefficients when you call summary. So if I do summary, whatever the model is, $coefficients, that allows me to directly see this table that might be familiar to you from looking at a lot of output from LM. And you can manipulate this table just like you would any other table. So if I put square brackets after this and say, hey, give me the fourth column, I'll get this column, which contains the p-values. I'm just showing you here that if I do summary, the model, and then say $coefficients, which gets me this coefficient matrix. And then I say, give me the fourth column. These are the p-values for the intercept on the first contrast and the second contrast. Does that make sense? Okay. So all I'm doing in this next line is I'm, saving those p-values in a particular place. I'm calling it p's. And then if I want to look at that extra contrast, the third contrast that compares white-collar workers to professionals, I have to pull that out from the other model that I fit. Then to use p-adjust, you just say p-adjust those p-values and tell it to use the Holm-Bonferroni method. There are a bunch of different methods that are implemented in p-adjust. I recommend the Holm-Bonferroni method if you want to check out what does it look like if we use the regular Bonferroni method. These p-values are also small that it doesn't make a huge difference, but generally the corrections will be more harsh if you're using the plain Bonferroni method.
So the Bonferroni is a little more conservative than the Holm.
Yes.
And then whenever you stored your coefficients in the p's, is it object or values? Is there a difference?
Could you repeat the question?
So whenever you store your coefficients in the p's, the ps, it creates a value in the environment.
Yeah, it creates
object.
It creates what's called a vector. A vector is a string of stuff. It's one thing, another thing, another thing. It has one dimension. An object is, in computer science, an object is a thing that you can manipulate using other stuff. So all these things that we're dealing with are objects. I think it's like a little bit more specific in computer science. An object has to have functions. It doesn't really matter. So when I say object, I mean anything that we created in R.
Right. And in that same function where you did the bracket notation at the end, 2:3, 4.
Yes.
What was
So,
the bracket?
Okay. The bracket notation, I don't know how much you've worked with it, maybe some. It's a way of treating things like spreadsheets. So this matrix right here is what we get when we say $coefficients, right? So this line up here gets us that matrix. We're only interested in these two values to the far right. So the 2 to 3 says, okay, give me the second and third rows. We're looking at these two rows. And then the thing after the comma tells R which column we want to work with. It says, give me the fourth column. So if I look down at the second and third rows in the fourth column, I'm pulling up these two elements right here. It's the p-value for the comparison between professionals and blue-collar workers, and for the comparison between white collar workers and blue collar workers. Is that clear? So okay, that's one of the adjustment methods. The second one is Scheffé. Scheffé doesn't work by adjusting p-values, it works by adjusting what you can term the critical value. It's like the t-value that you compare your observed t-value to say whether something's significant. And usually there's a p-value associated with it, but you can also directly adjust that critical value. The only reason that matters is that technically Scheffé doesn't have any p-values associated with it. It's kind of a weird thing. It doesn't matter that much most of the time, but the mathematically precise interpretation is that it's modifying the critical value, so there's no p-value associated with Scheffé. In order to use Scheffé, technically, this is a protected testing method. Protected testing means that you do that omnibus test before you go on to look at the model that you're actually interested in. So I'm just showing you how to do that using model compare. Using Scheffé is pretty simple. Yeah, go ahead.
Is the NA data, is that just a way of getting rid of the NAs and the?
Yes. In order to do a model comparison, you need the same number of rows of observations. And we have missing values on the type variable. So this is a way of dealing with that.
So what is the D here?
This stuff right here. Okay. What this is doing is, these are the data so I'm creating a smaller data frame that just has the prestige and the type variable because I don't want to omit rows that have missing values on other variables like income, for example. If there were missing values on income, I wouldn't want to omit those. NA omit says, look at this data frame that I've given you. It just consists of those two variables. And omit any rows where either variable has missing values. If I did not have this line, just to show you, and I fit this model and try to use model compare says, hey, look at that. The two models I'm trying to compare had a different number of cases that put into them. That's weird. That doesn't make sense. So that is telling you that you need to address something. And the way, one way you can address that is by filtering out any of the cases that have missing values for type, even though type isn't in this model. Right. The way Scheffé.test works is you need to give it a model with a factor variable, once again. And you can have any contrast you want set for that factor variable, it doesn't matter. One of the primary things that Scheffé.test is going to give you is a critical value to which you can compare other F values that you talked about. And that's a way to look at contrasts that are not dummy-coded, that don't compare one level to another. So if you want to test a linear contrast Scheffé test, you can grab that critical value and just compare your observed F value to that critical value. So that's the primary thing that's going to give you. This function also it does some of the pairwise comparisons for you. If those are of interest to you, fine. If you want to use the critical value to look at other contrasts, that's also fine. The nice thing about the Scheffé test is that even though it's very conservative, it allows you to look at any contrast you want. Right. So to do the Shapé test, you say, here's the model that you need. The second thing is the factor variable that you're interested in. And it's kind of quirky. The quirky thing about this function, by default, it doesn't print anything out here. It doesn't give you this output. It just does it silently. To have it print out that those results, you need to say console equals true. So that critical value that I was talking about, that you can grab and compare to other F values that you calculate on your own, that's right here, this 3.09. Yeah.
I'm seeing on our script it says group equals false before console equals true. So doing that. Oh, that's next.
Oh,
Sorry.
yeah. Yeah, I'll talk about what that does shortly. Anyway, this is one of the primary things that you're interested in. As I said before, it automatically also looks at the pairwise comparisons between groups. So like, what you get from dummy codes, which is one way that you could treat this or use the Shapé test. So that note about group equals false, that's a way to get, they're sort of like p-values, but technically they're not. It gives you this extra stuff with p-values and confidence intervals. And like I said, technically they're not p-values for all practical purposes. You could treat them as if they're p-values. I couldn't find anybody who said that it's like a real problem to not treat them like p-values. So I'm just showing you here that you can do Shapé tests on other kinds of contrasts if you want. So this is a linear and quadratic contrast. In order to do that, in order to do a Shapé on those contrasts, you just fit the model as you would normally do, and LR to give you F values, it's t squared, so they're just a transformation of each other. But you can then compare V's that you get from the model to the critical value that you got from the Shapé test. And if that, the value that you observe is larger than the critical value, that indicates a significant difference. That's it. That's all the new stuff. So for the rest of the class, go ahead and download that exercise and try to work through it, and let me know if you have questions. And please do ask questions. The whole point of this is that you're working through some of the stuff while I'm actually here. And I'll post a key after lab if you want to compare what you did to the key. Do you feel the light? Thanks.
Yeah, I did it before we went to class.
I just wanted to